So from the center, we'll go a little bit more than 5 spots in each direction, just past 5, and connect those to make the circle. And that would be the graph for the question. Title of last section is write each in standard form and graph. First equation and only equation for this section is x squared plus y squared plus 4x minus 6y equals -4. Again, a good idea to put this in standard form is to first figure out what type of graph it would be. We have two variable squares, x squared and y squared. They are both positive and have the same coefficient, so this graph would be a circle. To factor this, we'd have x squared. Then we can bring the 4x next to it, and completing the square, we'll add a number to that in just a minute. Afterwards, we'll have y squared, and the minus 6y we can put next to that, and again we'll add a number to complete the square in just a minute. Equals -4. Completing the square on the x, again we'll take the number, divide by 2, and square it. So 4 divided by 2 would be 2, and squared would be 4. Since we add 4 to one side, we'll add 4 to the other side. And also for the y value, -6 divided by 2 would be -3, squared would be 9. And if we add 9 to one side, we'll add 9 to the other side. Factoring the x's, this would factor x squared plus 4x plus 4. That would factor to x plus 2 squared. And factoring y squared minus 6y plus 9. That would factor to y minus 3 squared. -4 plus 4 would be 0. Adding 9, it would be equal to 9. And this equation would be in standard form for a circle. To graph a circle, we want to find the center. Find the center again, you can do the opposite of the numbers next to x and y, which would be -2 and +3. And also for the circle, we need the radius, which again is the number. It's equal to 9, so we'll take the square root of 9, which would be 3. Graphing the circle, we can draw the xy axis. The center would be at -2, +3. And we'll go 3 units in each direction. So 3 units up, 3 units down, 3 units to the right, and 3 units to the left. Connecting all 4 points to make a circle shape. And that will be the graph for the circle. Solving the equation, since the absolute value is isolated by itself, we can first take the absolute value signs off to have 3 minus 6x equals 15. Solving from here, we can get our first answer. Getting rid of the positive 3, we can subtract 3 on both sides. Negative 6x equals 12. And dividing by negative 6, we'll have the first answer, x equals negative 2. There are two answers with negative 2. Letter B has negative 2 and D has negative 2. To solve the second answer, we can take the same absolute value and set it equal to the opposite, or negative 15. 3 minus 6x equals negative 15, and that's because if the absolute value is negative 15, taking the absolute value would still be positive 15. Subtracting 3 on both sides of the equation, negative 6x equals negative 18, and dividing by negative 6, we'll have the second answer, x equals 3. So the correct answer, x equals 3 and x equals negative 2. The correct answer would be letter B. Solving the equation, again we can set the absolute value twice to get two answers. Looking at the possible answers, letter B and C we know will be incorrect. Since they're not equations, they are inequalities. So a possible answer could be A or D. Solving the first equation, taking the absolute values off, we'll have 12 minus 4x is equal to 2. Subtracting 12 on both sides, negative 4x equals 2 minus 12 would be negative 10. And dividing by negative 4, we'll have the first answer, negative 10 divided by 4 would reduce to positive 5 over 2. 5 over 2 as a decimal would be the same as 2.5. Letter A has negative 2.5, which would be incorrect. So the correct answer would be D, x equals 2.5, and the other solution you could get by solving for negative 2. Solving for the number of roses that were bought. The first sentence with a dollar amount, the roses cost $15 per dozen. So writing the equation, that would be 15 times the amount of roses, or 15 times R. And adding to that for carnations, which are $8 a dozen, it would be plus $8 times the carnations, or 8 times C. The total amount paid, stated later on, is equal to 192. The second equation that we can write, there was a total of 17 dozen flowers bought. So the two variables, or the two amounts, R plus C, the number of dozen bought would be equal to 17. Solving from here, we want to look for the number of roses that were bought. So we want to solve for R. To solve for R, we can substitute the first equation. If we subtract R, or the second equation, if we subtract R, we'll have C equals 17 minus R. And using substitution, we can plug 17 minus R into the first equation for C and solve from there. Rewriting the first equation, 15R plus, and instead of 8C, we'll have 8 times the substituting value, which is 17 minus R, equals 192. Solving from here, since we have a single variable, we can solve for R. 15R plus 8 times 17. Multiplying that out would be 136, and 8 times a negative R would be minus 8R, equals 192. Continuing to solve, 15R minus 8R would be 7R, plus 136, equals 192. Subtracting 136 on both sides, 7R equals 192 minus 136 would be 56, and dividing both sides by 7, we'll have the answer r equals 8. So the correct answer, letter C, would be 8 dozen for the amount of roses. The restaurant manager bought 20 packages of bagels. Some packages had 6 bagels and the other packages had 12 bagels. If we use two variables, x plus y, for the two different types of bagels, the total amount of bagels or packages would be 20. For the 6 bagels and 12 bagels, if we let x be the package with 6 bagels, the number of bagels would be 6 times x. And if we let y be the package that has 12 bagels, the amount of bagels would be 12 times y. The total amount of bagels is equal to 168. And again, we can solve by substitution, or you could also solve by elimination. If we want to solve for the 12 bagel packages, the 12 bagel packages is the letter y. So we want to keep the variable y, but we want to eliminate or cancel out the x. So what we can do is multiply the first equation by 6, and we'll be able to eliminate the x's and solve for y, which are the 12 bagel packages. 6 times x, and 6 times y, and 6 times 20. Elimination, we can subtract, so we'll cancel out the x's. 12y minus 6y would be 6y, and 168 minus 120 would be 48. Dividing by 6 will give us the answer for y, and again y was the 12 package bagels. 48 divided by 6 would be 8, so the correct answer is B, 8. To find the point that lies in the solution set, we can take the points, plug them into the equations, and see which point works for both equations, or both inequalities. The first one, x negative 4 and y negative 1. 2 times negative 1 would be negative 2, and a negative x would be a plus 4, is greater than or equal to negative 6. Negative 2 plus 4 would be 2, and 2 is greater than negative 6, so the point works for the first inequality, and to make sure it's a solution, it should work for the second inequality as well. 2 times y, or 2 times negative 1, would be negative 2, and negative 3x, negative 3 times negative 4 would be positive 12, is less than negative 6. Negative 2 plus 12 would be 10. 10 is not less than negative 6. So A is not the correct answer. Checking letter B, plugging a 3 in for x and a 1 in for y. 2 times 1 would be 2. Minus x would be minus 3. Is greater than or equal to negative 6. 2 minus 3 is negative 1. Negative 1 is greater than or equal to negative 6. So the second point works for the first inequality, and checking the second inequality. 2 times y, or 2 times 1, would be 2. Negative 3 times a positive 3 would be minus 9, less than negative 6. 2 minus 9 is negative 7. Negative 7 is less than negative 6. So point B works for both inequalities, so the answer would be B. Solving the system of equations. If you want to, you could plug in the points for A, B, C, and D and see which set of points works. Otherwise, you could solve by substitution or elimination. If we do elimination, the second equation, to cancel out the y values, we can multiply by 3. Multiplying by 3 would be 12x. 3 times y would be 3y. And 3 times a negative 6 would be negative 18. If you combine the first equation and the new equation, the negative 3y and the positive 3y, we can add those together to cancel them out. And we'll have 2x plus 12x would be 14x. The y's again would cancel. And 4 plus a negative 18 would be negative 14. And dividing by 14, we'll have the answer x equals negative 1. Looking at the values, there's only one correct answer, has x equals negative 1, which would be the answer C. If you plug a negative 1 in, you could solve for y, which would be negative 2. Solving by long division, we'll need some term times 2x that matches up with 2x to the fourth. That term would be x to the third. X cubed times 2x would be 2x4. And multiplying a second time times the positive 7, 7 times x cubed would be a positive 7x cubed. Long division will subtract after we multiply. The first term again should always cancel, and 21 minus 7 would be 14x cubed. Dropping down the next term, plus 35x squared. And again, we'll continue the long division method until we get to the last term. 2x into 14x cubed would be positive 7x squared. 7x squared times 2x would be 14x cubed. And 7x squared times 7 would be 49x squared. Subtracting again, the first term should cancel. 35 minus 49 would be negative 14x squared. And bringing down the next term, negative 37x. 2x into a negative 14x squared would be minus 7x. Minus 7x times 2x would be negative 14x squared. And negative 7x times a positive 7 would be negative 49x. Subtracting again, minus a negative 14x squared would cancel. And subtracting the negative 49x would change us to a positive 49. So negative 37 plus 49 would be 12x. And bringing down the last term, 46. 2x into 12x would be 6x, or would be actually 6. 6 times 2x would be 12x, and 6 times 7 would be 42. Subtracting again, 12x would cancel. 46 minus 42 would be 4. Since this is our last number and last term, that's the remainder. The remainder will be a fraction. 4 will be the numerator. And 2x plus 7 will be the denominator. Looking back at the possible answer choices, the correct answer would be D. Multiplying using the distributive property, we can multiply each term in the first parentheses by each term in the second parentheses. If we multiply 2x times each term 3 times, 2x times 3x squared would be 6x cubed, and 2x times a positive x would be plus 2x squared, and 2x times a negative 4 would be minus 8x. Multiplying again each term by negative 5. Negative 5 times 3x squared would be negative 15x squared. Negative 5 times a positive x would be negative 5x. And the last terms, negative 5 times negative 4 would be positive 20. 6x cubed is the same in each of the answers. Plus 20 would be answer B or D. C and A both have a negative 20, which would be incorrect. Combining the x squareds, we should have a negative 13x squared as well as a negative 13x. So the correct answer in this case would be B, 6x cubed minus 13x squared minus 13x plus 20. Simplifying, the second parentheses we can distribute to negative 2. Negative 2 times 4x squared would be negative 8x squared. Negative 2 times a negative 3x would be positive 6x. And negative 2 times a positive 1 would be negative 2. Combining the first parentheses with the second distributive parentheses, negative 2x squared minus 8x squared would be negative 10x squared. 6x plus 6x would be 12x. And a positive 1 minus 2 would be negative 1. So the correct answer, negative 10x squared plus 12x minus 1. Correct answer would be letter D. Multiplying using FOIL, 6y squared times 6y would be 36y cubed. The outside terms, 6y squared times 2 would be plus 12y squared. The inside terms, negative 2 times 6y would be minus 12y. And the last terms, negative 2 times 2 would be minus 4. So the correct answer, 36y cubed plus 12y squared minus 12y minus 4. Correct answer would be D. Multiplying again, we can multiply each term in the first parentheses by each term in the second parentheses. 5x cubed times 3x squared would be 15x to the 5th. And 5x cubed times positive x would be plus 5x to the 4th. And 5x cubed times a negative 8 would be negative 40x cubed. And multiplying each one by negative 2, or negative 2x. Negative 2x times 3x squared would be negative 6x cubed. And negative 2x times a positive x would be negative 2x squared. And the last term, negative 2x times a negative 8 would be a positive 16x. So the correct answer, 15x to the 5th plus 5x to the 4th. Combining the x cubes would be negative 46x cubed minus 2x squared plus 16x, which would be C. The formula for sum of cubes is a cubed plus b cubed is equal to the first parentheses a plus b, and the second parentheses is a trinomial, which is a squared, then the opposite sign minus a times b, and plus b squared. In this case, a and b, the cube root, 8a cubed would be 2a, and c cubed would be c. Plugging a 2 in, 2a where a would be, and plugging a c where b would be, the correct answer is D, 2ac, or 2a plus c. Squaring the 2a will be 4a squared, and minus 2ac, and b in this case would be c squared. The total area of the rectangle is the difference of squares. Taking the square root of the first term, 4x to the fourth, that would be 2x squared. And the second term, 9y squared, taking the square root would be 3y. The difference of squares will have two parentheses, each parentheses one with a plus and one with a minus. So the correct answer would be A, 2x squared minus 3y, and 2x squared plus 3y. The factor of this again is the difference of squares. X plus 1 squared, taking the square root would just be the parentheses x plus 1. And y squared, taking the square root would be y. And again, two parentheses, x plus y and y, one term with a plus and one term with a minus. The correct answer would be D, x plus 1 plus y, and x plus 1 minus y. Factoring, we can first take out a common factor from 12x squared minus 47. A 3 would be a common factor of each. Dividing by 3, we'll have 4x squared. And 147 divided by 3 would be 49. The term that's left over, 4x squared minus 49, is again a perfect square or difference of squares. The square root of 4x squared would be 2x. The square root of 49 would be 7. And again, we'll have 2x plus 7 and 2x minus 7. So the correct answer would be D, the 3 that we factored out, and 2x minus 7, 2x plus 7. Checking the factoring, the answers A, B, C, and D. The answer B in this case would be incorrect since we have a cubed exponent, which will give us x to the cubed and y cubed. And since we do not have x cubed or y cubed, B would be incorrect. Also, letter D would be incorrect since this would be a single term, but we cannot factor out the plus and minus. With factoring, we'll have more than one term. To see if the answer is A or C, we can try factoring the original expression into two parentheses. The first term, 25x squared. One way to factor would be 5x times 5x, which will give you 25x squared. And the last term, plus 16y squared. 16y squared, we could use 4y and 4y. And we could have positive 4 and positive 4, or also negative 4 and negative 4. Since the middle term has to add up to negative 40, trying the negatives, the outside terms would be negative 20xy. The inside terms would also be negative 20xy, which will match up with the negative 40xy. So the two parentheses or two factors, 5x minus 4y and 5x minus 4y, is the same as letter A. To add rational expressions, we first need common denominators. The second fraction, x squared plus 3x minus 10, we can factor. Numbers that multiply to get negative 10 and add to get positive 3.